So metal exercise 2, the first 7 already done. So we'll solve from question 8 and onward. You can use a screen annotation or you can use a chat to state the answer. Starting with question 8. Copper 2 nitrate, a compound copper 2 nitrate decompose when heated. Whenever a metal nitrate is heated, from calcium to copper, it will give a metal oxide plus carbon dioxide plus nitrogen dioxide plus oxygen, and or a brown gas is given now. So in the question, copper 2 nitrate decompose when heated two gases. One is oxygen, another one is nitrogen dioxide, and a solid was made. A sample of a copper 2 nitrate was decomposed using the apparatus shown. So when we supply heat energy to copper 2 nitrate, it releases two gases. One is oxygen, another one is nitrogen dioxide. And this solid, it was originally copper 2 nitrate, but then it will turn into copper oxide. And when we pass this through aqueous sodium hydroxide, because nitrogen dioxide is a non-metal oxide or acidic oxide, so it will dissolve or react. And only what gas we will collect at X, that will be oxygen. Why there is no more nitrogen dioxide? Because nitrogen dioxide is a non-metal or acidic oxide which will react with an alkali. So the first part, complete the chemical equation for the reaction. So we have to complete the equation for a reaction here. So copper oxide. And then we have to balance as well. Balance this equation. Copper oxide is there. What will be the coefficients to balance nitrogen dioxide and copper oxide? This 2 is multiplied with nitrogen 2 as well. So 2 multiplied by 2, that makes 4. So when we write a combined equation, so it will be 4NO2 plus 2Cu. Is it clear?
Yes, sir, clear.
Only oxygen gas is collected at X. What is the reason why we collect only oxygen gas? So, yeah, what's your
Because
answer?
the nitrogen dioxide, that's acidic oxide, reacted with sodium hydroxide, which is alkaline
Yeah.
solution.
So nitrogen dioxide is acidic, and as a result, the acidic oxide will react with sodium hydroxide or an alkali. In question 9, the iron does not rust when it is completely coated with zinc. When zinc is sprayed, the iron still does not rust. Explain why the iron does not rust when it's completely coated with a zinc. Look, first thing, even if it's not zinc, if it was any other metal, iron won't rust. Why iron would rust? Even it was a copper, even if it is completely coated with that. So what is the reason for that? When it is completely coated, why it does not rust?
Because it prevented the oxygen and water to
Yeah. So basically, the first answer, you cannot write zinc more reactive than oxygen. That is the next part. In this part, why it does not rust? What is the reason for that? Because the layer of a zinc is preventing oxygen and water to have interaction with iron. Like it's like a barrier. It does not allow oxygen and water vapors or water molecules to interact with iron. So here we don't mention zinc is more reactive here. Even the same question was there. Even this was the same question, and they said iron does not rust when it is completely coated with copper. Say this sentence was not there. So if iron does not rust when it is completely coated with copper, what is the reason for that? The reason is not about the reactivity. The reason is because that layer preventing the oxygen or water molecules to interact with the iron. So even it's a more reactive metal layer or a less reactive metal layer, both cases, why it does not rust? What is the reason? Because they are preventing iron to interact with oxygen or water. So the answer here is not about the reactivity. Answer is it prevent iron, or it prevent air, or you can say water and oxygen to interact with iron. So it's like a barrier, or provide a barrier between the water, oxygen and iron. That's why it does not rust. But the next one, yes, you can use screen annotation. As I mentioned, it's good. It's also good like you use screen annotation or a mic or a chat. So I don't have to type. Anyone want to just type, write, it's good. If you know the answer, you can type, or you can use the screen annotation. So the next question is usually like 3 mark to 4 mark question in which you have to compare. 1 mark is for comparing the reactivity. So the zinc is more reactive than iron. That is 1 mark. So zinc can lose electron easily, or zinc can oxidize. That is the second mark. And the third mark is the transfer of the electron. Like, or you can mention like zinc loses electron easily or oxidize, second mark, or electrons are transferred from zinc to iron. Or zinc to oxygen or zinc to water, not iron. Not iron to oxygen or. So that's how you score the marks. In question 10, the position of aluminum in the reactivity series of the metal, you can see it's shown like as we go down, the reactivity is decreasing: magnesium, aluminum, zinc, and copper. Aluminum is extracted by electrolysis of the molten oxide, which is usually aluminum oxide. We use anode and cathode are made up of graphite. Name the main ore of aluminum. So what is the main ore of the aluminum? That is bauxite. Why does molten electrolyte contain cryolite? What is the advantage? What is the advantage of using a cryolite? The cryolite will lower the melting point. It reduce the melting point. That's why we use cryolite. Because without cryolite, it will melt around 1900 degrees centigrade. Then oxygen is produced at a positive electrode. Name another gas which is given off at that electrode. So the gas which is produced, that's right. You can use your mic, chat, or screen annotation to answer. Those who are answering in a chat, it's also fine. You can use that. So carbon dioxide is a gas. Aluminium react very slowly with a copper to sulfate solution, as you can see. Which two metal has a greater tendency to form an ion? Which two metals have a greater tendency to form ions? You can see from this, the reactivity series is shown.
Magnesium and aluminium.
The more reactive metals, they have a greater tendency to lose electron or form an ion? But with reference to the question, because they asked which of the two metals, like usually when we talk about the series in terms of reactivity series, in this series, magnesium has or aluminum are the two. But the question is with reference to this equation. So which of the two metals has a greater tendency to form an ion? Is it aluminum or copper?
Aluminium.
Aluminum, because the more reactive metal can displace the less reactive, so they have tendency to turn into an ion. So aluminum, you can say. Describe what you see when this reaction occur. So what will be the observation here? Blue. So if I write the color and you can write from that, it's good you are using screen annotation, those who are using, or chat, you can also use the chat. Look, aqueous copper 2 sulfate is blue in color. And group 1, 2, 3 salt solutions are colorless. And what is the appearance of a copper? Copper is a brown or a pink solid. So what is the observation? What will happen? The blue color will disappear. Like because copper 2 sulfate is blue and aluminum sulfate is colorless. That is one thing. Solid dissolve is not 100% correct. Why it is not 100% correct? Because here one solid is dissolved and another solid is formed. So the best observation when you write here, the best thing you will write here, you will mention the color, the blue color disappear or a solution show color change. From blue to colorless. That is one basic observation. And then aluminum added to this, it's form a copper. So we'll say a brown or a pink solid form. Is it clear, this one?
Yes, sir, clear.
This is exercise 2. Those who just joined now, this is exercise 2 from metal and inspection. That is also a weekly homework. I'll try to solve this exercise as much as I can, so you will have an idea how to solve the remaining of it. Well, aluminum reacts so slowly. What is the reason for that? Any idea? If you have a
I
piece,
think
yeah,
because it has oxide layer.
yeah, because it has a covered oxide or aluminum is covered with oxide layer or it has oxide layer, coat of aluminum oxide or oxide layer. That's good. Because aluminum oxide is not reactive as compared to aluminum. So aluminum always have an oxide layer. It's usually react. Once the oxide layer is removed, then the reaction will start. Complete the following table by writing a reaction and no reaction in a space. We have a basic oxide. So basic oxide can react with acid, that's true. And with alkali, they don't react, no reaction. Amphoteric can react with both acid and alkali, that's good. You can use the chat, you can use a screen annotation or a mic to state the answer. Moving on to the next question. Predict the equation for a decomposition. Whenever a metal hydroxide decomposes, it gives metal oxide plus steam. So first we have to write the formula for aluminum oxide. So aluminum is group 3 plus 3 and oxygen is group 6 minus 2. So formula for aluminum oxide will be Al2O3. And for steam, H2O. Now the second part, why it's of 2 marks, second part is for balancing. Balance this equation. The screen annotation or a chat or a mic to state the right balancing. 2 here, that's good. What about hydrogen? This is aluminum is balanced already. What about hydrogen and oxygen? What we should put here? Because this equation is not balanced in terms. Now it is. Why 3 by 2? If you check here, when you put 2 here, like aluminum hydroxide gives aluminum oxide on decomposition plus steam. So when we are balancing, if we put 2 here, 2 aluminum is all. What about oxygen? Like this 3 multiplied by 2, 6. So 3 are there. So we put 3. 3 multiplied by here 3 and 3, 6. And hydrogen 3 multiplied by 2, 6. 2 multiplied by 3, 6. So it should be 3 here. Aluminum nitrate, here we have to write a word equation. Whenever a metal nitrate is heated, from zinc, from calcium till copper, they have the same products. So aluminum oxide, good. A word equation we have to write nitrogen dioxide usually form. Nitrogen dioxide, it should be di here. And then one of the product will be oxygen. So whenever a metal nitrate is heated, nitrogen dioxide plus oxygen plus metal oxide will be nitrogen dioxide, the full nitrogen dioxide. If any question you find it difficult or you're not able to understand, just let me know. So I'll repeat that. You can use the screen annotation to take 3 properties of transition element, iron. Actually, if you read the question, you have to tick 3 boxes. And here I see 4. Why this one is not correct? Because the metals are highly colored. That is not, if this was there, their compounds are highly colored, then this will be a tick here. But its metal are highly colored. That is not the correct statement. Their compounds are highly colored compound, like variety of colors are formed. The compounds, the metal and the compound are often a catalyst. That's true. And they have more than one oxidation state. In which period in the periodic table we found iron? Which period we found iron? The horizontal rows are representing the periods. So when you check the period, so the first period is having two elements. The second period, third period, and the fourth period. So where we found this iron is found in the fourth period. So iron is found in the fourth period. Then you have to use a periodic table, work out the number of proton in an iron. Iron is 26 and 56. So how many protons are there and how many neutrons are there? So number of the protons that are 26. Number of neutron, we just take a difference, 56 minus 26. So that is 30. Then In extraction of iron in the blast furnace, the list below gives some substances which are used. Which substance is a mineral containing lightly calcium carbonate? That is a limestone. Good. Then which substance when impurity which substance is formed when impurity in the ore reacted with calcium oxide? So it will form a slag. And which substance is also called hematite? So that is the iron ore or ore of the iron. Two functions of a coke used in the blast furnace. Why we use coke or a carbon in the blast furnace? What is the reason? One is because it burn to produce heat
To
energy.
react
Yeah. One is to burn, produce heat. What else?
and to react with carbon
Hmm.
monoxide to form carbon dioxide.
Or
Sorry. React with carbon dioxide, I think, to form carbon monoxide.
yeah. If you directly write remove impurity, yeah. Look, the simple points will mention. First thing, it burn to produce heat, increase temperature, or burn to produce heat. The second thing, it can also be a reducing agent because carbon is a reducing agent, or produce carbon monoxide, which is a reducing agent. Like it can, when carbon react with oxygen, give carbon dioxide. That is one use, produce heat energy. Carbon dioxide further react with more carbon or a coke to produce carbon monoxide. And this carbon monoxide is a reducing agent. The most of the iron is converted into a low carbon steel or a stainless steel. Give one use of each. What is the use? Good car bodies. And high carbon steel, cutlery, kitchen, chemical plants you can also mention. Cutlery, kitchen, chemical plants, you can mention any of them. The next one, some reactions of a metal W, X, Y, and Z. And you can see when metal X, few bubbles are there. And with hydrochloric acid, vigorous reaction, a gas is given off. With X, vigorous reaction, metal melts, gas given off, explosive reaction. Metal Y does not react at all, and metal Z does not react with cold water. Uh, which is the most reactive? So from this order, we identify like Y should be the least reactive, X is the most reactive, Y should be the least reactive. That's right. And then we have to check between W and Z or Z. So when you check W with Z, few bubbles are there and does not. So it means like few bubbles, that means W is reacting more than. So it will be X, W, Y, and Z. And because you have to write, you can write in row as well, but because you have to write as they provide the space, so you have to write in the sequence. Which metal could be magnesium? Like we have different metals, which you can think could be a magnesium and which is copper. Copper, just a minute, I will zoom out so you can use screen annotation. Now, which one you think is magnesium? When we talk about the correct answer, magnesium is actually W and copper is Y. So when we talk about the reactivity, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, and then copper. So from potassium, sodium, and calcium, they can react with cold water. Like they're high, they can, and then magnesium, so they can react slowly with very slow with cold water and usually react with steam till iron. So what we need a more reactive metal here, because like in terms of here vigorous reaction, why we don't say it can, because potassium, sodium, and calcium can react with a cold water easily. So it cannot be here. Why we say X cannot be magnesium, because the metal X is vigorous reaction. A metal melt and a gas is given off. So X is reacting vigorously with the cold water. So it cannot react vigorously with the cold water. That's why we say this X cannot be the magnesium. So after X, what else we have? This Y is no reaction. And when you talk about the copper, copper does not react with water nor with steam, or it does not react with dilute acid. So that's why copper is Y. Then after that, we are left with, because we want to work out which is X cannot be magnesium. Why X cannot be magnesium? Because it is reacting vigorously with the water, but magnesium does not react vigorously with the cold water or a normal temperature water. It cannot be Y as well. Does not react with a cold water, hot metal, react with steam. So this point, because like sodium, potassium, sodium, calcium, they can all react with cold water along small, very small amount of a magnesium can react with. But when you check about the reactivity here, with like this might be magnesium, W might be magnesium, or Z can be magnesium, according to the first column. When we check reaction with acid of these metal, potassium, like they all can react with acid till here, till, because lead, we have the reactivity series, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. Carbon is between aluminum and zinc, and hydrogen is there between lead and copper. So till here they can react with dilute acid. And these are highly reactive metals, so they can react much quicker as compared to here. It shows steady phase. So when we work out, or when we are finding the position here, because it is reacting with acid and the reactions are much faster, like for W, it is a vigorous reaction, a gas is given off. And here, steady phasing is there, like constantly gas is given off, but the reactions are not fast. But magnesium is in the higher side of a reactivity, so it should react quickly. That's why W is the most appropriate like closer to magnesium. And why? Because it does not react with, yeah, magnesium is more reactive in acid than in water. Is it clear, this one? Like why a metal W is magnesium?
Yes, sir, clear.
The next one, the equation for X with the cold water is shown. When metal X is reacting with the cold water, describe a test you use to we want to test a hydrogen. So hydrogen lighted splint and it will pops. So lighted splint, it will pop. How could you show that the water contain a compound of type XO, like X, XNOH, like it's an alkali? How we can show that? It's of 2 marks. How we can say the
Add
compound,
universal indicator.
and then what will happen? 1 mark is for add universal
It will
indicator.
change to blue.
So universal indicator turned blue because it's of 2 marks. Or you can mention measure the pH. The pH will be because it's a group 1 hydroxide, so likely it will be more alkaline solution. So pH 10, pH 12, you can mention. In which group of a periodic table this belongs to? How you identify that which group it belongs to? So it belongs to group 1. How we identify that it belongs to group 1? Because the hydroxide have a valency of -1. So this element metal should have a valency of +1, so it will be XOH. If it was a group 2 hydroxide, then it will be XOH bracket 2. If it was a group 3 hydroxide, then it will be XOH in a bracket 3. So using this, we can, here you cannot say that react with acid, because reacting with acid is not a, like, metal can also react with acid, metal oxide can also, metal hydroxide. So reacting with an acid is not an identification of an alkali. You should test either by measuring a pH or using a universal indicator. The ore of X is a chloride. Suggests how metal X could be extracted. If I want to extract the metal from its chloride, a group 1 metal from chloride, which are highly reactive, which technique we should use?
Maybe electrolysis.
Electrolysis of molten compound. Not only electrolysis, you have to mention by doing electrolysis of the molten compound. Why heating with coke is not acceptable? Because when you check the reactivity series, you have sodium, potassium, sodium. So group 1 metals are highly reactive. So metals which are below aluminum can be heated with coke. For highly reactive metal, always we do electrolysis of the molten compound. So we do electrolysis of the molten compound for highly reactive metal. It won't work. Why it won't work? Because it's like a group. Like if I say I have potassium chloride and I heat with coke, carbon is less reactive than potassium. Carbon cannot displace this potassium from its compound. That's why there will be no reaction. So highly reactive metal, we should always do electrolysis of their molten compound. That's why for aluminum extraction, for extraction of aluminum, we don't heat with coke. We do electrolysis. Question 13, aluminum is extracted in electrolysis of molten mixture that contain alumina. The ore of aluminum is a bauxite which contain alumina, which is amphoteric, and iron oxide is a basic. So if we add sodium hydroxide, so which will dissolve or which will react? Yeah, good. Aluminum oxide will dissolve and iron oxide, because why? Aluminum oxide, they mention it is amphoteric. Amphoteric can dissolve or react with both. We can remove by filtration, that it does not dissolve. And when aluminum oxide dissolve, it will become aluminum hydroxide. Label the diagram. A negative terminal, what we call, and what from what it made from. So carbon cathode is there. What we have a mixture here. Temperature 900, good. Carbon cathode. What we have a mixture of aluminum oxide and cryolite. And what is this substance which we collect? Aluminium or not slag. Here we don't get slag. Slag is there in extraction of iron. This is aluminium, extraction of aluminium, which produce aluminium ion and oxide ion. These aluminium ions attracted towards the cathode, the base and the wall. And we have a molten aluminium, you can also say. Aluminium or a molten aluminium. Then write the equation for reaction at cathode and anode. At cathode, aluminium will move and it will turn into aluminium metal. Aluminium plus 3, take 3 electron, turn into aluminium metal. And why carbon dioxide is formed at anode? What is the reason for formation of a carbon dioxide?
Because the anode is made from carbon.
Okay, and then carbon react with oxygen. Oxygen evolve, react with carbon. Right. So carbon react with oxygen to form carbon dioxide. The next page, quickly I'll move to next page because about a minute left. Give an explanation of each of the following. Aluminium is used extensively in manufacturing aircraft. What is the reason why we use for aircraft bodies? Low density and strong also, you can mention strong as well. And resist corrosion. Non-toxic is not the right term. It should be resist corrosion. Toxic is usually used for, rather than for a metal, it's usually used for compounds, substances which are formed. And high conductivity. So low density or strength, high resist corrosion or high conductivity. That's why aluminum can be used for these uses.